All right, algebra, let's check out 12.4. So in this topic, we are simplifying rational expressions. So similar to what we've been doing, but a little bit different look. So a couple things to keep in mind is that a rational expression is any expression that can be written as a ratio, or in other words, a fraction of two polynomials. So the only time a rational expression is undefined is when the denominator is 0, which we already knew. So any number that makes a rational expression undefined is called an excluded value. So if my denominator is x minus 3, then an x value of 3 would make the denominator have a value of 0, so that would be an excluded value. And we say that a rational expression is in simplest form if the numerator and denominator have no factors in common other than 1. So even though we're going to have addition and subtraction and exponents and variables going on, we still treat this just like a regular fraction, and it simplifies the same way. Let's keep in mind we're always going to factor first before simplifying, and we talked about that in class a bit today. So let's start by finding any excluded values for the expression. To do this, I'm going to factor first if possible. In this first example, I can't factor it further, so I'm going to set my denominator equal to 0 and solve for x. Whatever values would make this equal 0 are my excluded values. So in this case, x cannot be 0. That's my excluded value. On part B, I again am going to factor first if I can, and in this case I can factor my denominator, so I'm going to factor out my greatest common factor, which is 3, and that leaves me with x minus 3 in parentheses. So now I will take my denominator and set it equal to 0 and solve. So first I'll divide both sides by 3. And now to solve for x, I'm going to add 3. So my excluded value, the only value that x cannot be in this rational expression, is 3. On part C, I again need to factor first. I can't factor my numerator. It's going to stay x plus 2, but I certainly can factor this polynomial. So I'm looking at factors of negative 15 that will add to positive 3. So immediately I'm thinking 5 and 3. And I probably want my 3 to be negative and my 5 to be positive, because 5 minus 3 would give me this positive 2 middle term. So I'm going to factor this to x plus 5 times x minus 3. Now I'm looking for an excluded value, so I'm going to take each of these factors and set them equal to 0 separately and solve. So here my excluded value would be 5 because, I'm sorry, negative 5, because that would make this factor equal 0. And over here, if I add 3 to both sides, then I find that the other value I need to exclude is 3. So x cannot be negative 5 and x cannot be 3. For part D, I'm again going to factor first. Again, I can't factor my numerator, but I can factor my denominator. So I'm looking for factors of negative 12 that will add to 4. So I'm thinking of 6 and 2 here. A 6 minus 2 would add to 4. I'm going to factor this to x plus 6, x minus 4. So in this case, I'm going to set each of my, or I'm sorry, not 4, 2. The 2 gives me the 12. 2 times 6 is 12, and the 6 minus 2 gives me 4. I don't need a 4. I need a middle term of 4. So I'm going to set each of these factors equal to 0 and solve them separately to find my excluded values. So I can subtract 6 from both sides, and I find that negative 6 cannot be one of my solutions. and that positive 2 cannot be one of my solutions. Those are my excluded values. The next thing we need to know is how to simplify if we can, and then we always need to state those excluded values. So because sometimes they will be included in our solution set unless we know to get rid of those. So just remember, always factor first. So as I look at number 1, x plus 3, x plus 6, I cannot cancel a term that's part of an addition or subtraction expression. So I can't just come here and cancel these x's because they are part of an expression, so I can't pull them out separately. So instead, I'm going to factor if possible. I don't have any common factors. My pen back. So I can't factor these at all. So instead, what I will do is just state excluded values. So in this case, x cannot equal 6. 10x divided by 35. I can't factor, but I can reduce because all I have is multiplication going on. So I can cancel my 10 and 5. They both can be divided by a factor of 5. So this would reduce to 2x over 7. And there is, in this case, there is no value that would make my denominator equal 0, so there are no excluded values. Let's check out number 3. In number 3, I have 2x minus 14, and I know I can definitely factor out a common factor here. If I factor out a 2, it leaves me with 2 times x minus 7, and my denominator is 7 minus x. However, I notice that this is very similar to this, so what I'm actually going to do here is I'm going to factor out a -1 or a negative sign and change the signs in here so that this factor is actually the same as this, and now I can cancel. Notice I'm not canceling a portion of my addition or subtraction expression, rather I'm canceling this entire factor. So those are exactly the same, so those can cancel. So I'm left with 2 on top and a -1 on the bottom. However, I do need to consider that there is a value for x that would make my denominator equal 0, so I need to tell the excluded values here. So in this case, I'm going to set my denominator equal to 0, and if I add x to both sides, we find that x cannot equal 7. So this is my solution, and this is my excluded value. And number 4, I don't have any addition or subtraction going on, so I don't need to factor, but I can cancel any common factors. So 24 and 32 can both be divided by 8. And y cubed can be divided by y squared. So if I have 3y's in my numerator and 2 in my denominator, then 2 of these will cancel with 2 of these. So as we simplify here, I have -24 divided by 8 is -3. I only have a y left, and in my denominator, 32 divided by 8 is 4, and I have no y's left. So my solution, or my simplified expression, is -3/4 y, or -3y over 4, but I also need to list excluded values. In this case, the only number I could put in my denominator for y that's going to make it equal 0 is 0 itself. So y cannot equal 0. And number 5, I'm going to factor first if I can. I can't factor my numerator, but I have a difference of 2 squares in my denominator, which I know will factor using my special products rule, x plus 5, x minus 5. So now I have a common factor on top. It cancels with a common factor on bottom, meaning I have nothing left in my numerator except a 1. And in my denominator, all I have is x plus 5. I do need to include my excluded values. So if I set this equal to 0, then x cannot be -5. And if I set this equal to 0, then x cannot be +5. Those are my excluded values, and this is my simplified expression. Okay, last two. Definitely want to factor on this so that I can simplify. So I'm looking for factors of 10 that will add to -3. Just about the only factors of 10 I can come up with are 5 and 2. And if I do a -5 and a +2, then those will add to -3x. In my denominator, I'm looking for factors of -12 that will add to -4. So I'm looking at a 6 and a 2. So if I do a -6 and a +2, that will give me my -12 third term, but also will add to -4x. So now I can go ahead and cancel any factors in common. This entire factor cancels with this entire factor. So my simplified expression is x minus 5, x minus 6. Remember, I can't simplify that anymore because I can't cancel my x's because they're each part of a subtraction expression. But I do need to give my excluded values. So I'm going to set each factor in my denominator equal to 0 and solve. So x cannot equal 6 and x cannot equal -2. Those are the exclusions. And finally, number 7, definitely want to factor first. This one I'm probably going to want to factor by grouping. So remember, to factor by grouping, I'm going to take this middle term, a positive 5x, and I'm going to break it apart into two pieces. So those two pieces need to add to 5x. So I'm going to make this a plus 2x plus 3x. And that way I can factor a 2x out of these first two terms, and I can factor a 3 out of these second two terms. So let's rewrite what we've got. We now have 2x squared plus 2x plus 3x plus 3. So I haven't changed the value of this. I have just taken 5x and split it up into two smaller pieces. Now, let's keep working right here. Now I'm going to go ahead and out of these first two terms, I'm going to factor out a greatest common factor, which is 2x. So if I factor out a 2x, all I'm left with is x. And if I factor a 2x out here, all I'm left with is a plus 1. Okay, and then out of my next two terms, oops, I'm going to put that there because I'm not multiplying, I'm still just adding. Now I'm going to factor out of a 3x and a 3, I'm going to factor out a 3. And that's going to leave me with x plus 1. That is all over negative 2x minus 3. So now I have this x plus 1 factor in common, so I'm going to factor that out. And what that leaves me with is a positive 2x and a positive 3. Might remember this factor by grouping from chapter 9. I also notice that I have a 2x plus 3 factor, and my denominator is negative 2x minus 3. So I'm going to factor out that negative 1, and that's just going to flip the signs on each of these terms so that now it can cancel. So now I have this common factor that will cancel, and all I'm left with is x plus 1 on the top and divided by a negative 1 on the bottom. So I could rewrite this way if I like. And now we need to look at what values to exclude. So as I look at my denominator, negative 2x minus 3, I need to set it equal to 0, so I'll start by adding 3. That gives me -2.